Hi hack friends, so I think we're on week 3 now of the virtual videos, so I'm going to do some science today with you. So for our lesson, we're actually going to be making a lava lamp, which is pretty cool. You can do this at home. You should have most of the ingredients, so we need water, oil, food coloring, and then the only thing you might not have, but it's very easy to get and it's very cheap, you can get it at the dollar store or the grocery store, is an Alka-Seltzer tablet. I have this at home because I have a retainer that I wear at night, so this just cleans it, but like I said, they're very easy to get at the store. You just need one of these for the experiment. So for our lava lamp experiment, I first wanted to teach you guys about density. So density is how tightly molecules are packed into different substances. So in this case, we have oil and water. Canola oil, you would think would be more dense than water, like you'd think it'd have more mass, so it would be heavier. But really what surprised me when I was learning about this experiment is that water is actually more dense than canola oil. So water, the molecules in water are way more tightly packed together than they are in the canola oil. So that makes water actually more dense and have more mass than the canola oil does. Okay, so to explain and to see how the densities differ, I'm gonna start off the experiment by first pouring in my oil, my canola oil. This is just a pickle jar, just use any type of container. So I'm probably gonna pour in about that much. Should be good. And then we're gonna pour in our water. So like I said before, the water is more dense than the oil. So what should happen is when I pour in the water should actually float to the bottom because it's gonna have more mass. So we'll see if that's the case. And it's gonna settle, yeah. So when it settles, the oil now, as you can tell, is gonna be at the top. So that's pretty cool. I'm gonna pause the video. I'm gonna put in a little bit more water actually, just so it's a little bit even, because I think I had a little bit extra oil. All right, so I'm back. I just put in a little bit more water so that it's equal half and half. So now the oil and the water are both pretty close to being the same amount. So the second concept I want to talk to you guys about is called polarity. So polarity is when you examine molecules. This is in chemistry, so you might have learned about this, maybe not, but you'll definitely learn about this in high school. Polarity refers to the charge that a molecule has. So not all molecules have charges. Oil is actually really unique because it has no electrical charge. So molecules like water can either have a negative or positive charge, which is referred to as polarity. So in this case, water, which is H2O, means that it has 2 hydrogen molecules and then 1 oxygen molecule. I have notes, yeah, I'm gonna refer to those real quick. So hydrogen in water's case is positively charged. So you have 2 hydrogens, meaning 2 positively charged atoms, and then the oxygen actually has no charge. But regardless, the polarity of water means that water itself has a charge versus oil does not have a charge. So polarity is what prevents water and oil from actually mixing together when we combine the two. All right, so now that I've explained density and polarity, we're gonna drop in our food coloring. So I'm gonna do a few drops, probably around 5. And the food coloring is more dense than the oil, so you're gonna notice that it's gonna sink to the bottom when we put it in. So 1, 2, 3, 4, 5. I'll do 6. Actually, I'll do 7 because that's a lucky number. All right, so as you can tell, the food coloring is sinking. It looks like it's kind of actually stuck on the surface there, which is interesting. So that's the food coloring. All right, so the third step to see the lava lamp is we're gonna put in our Alka-Seltzer tablet. So this is gonna create CO2 gas bubbles, and as soon as I drop this in, the CO2 gas bubbles, similar to water, they have an electric charge. So that means that they're gonna attract and stick to the water because of that charge. So you can see I'm gonna drop it in here. And perfect. So looks like the bubbles are floating to the top. Hopefully you can see this on camera. I think I put a little bit too much food coloring, so you might not be able to see it as best, but the bubbles here are all rising, similar to a lava lamp. all in that corner there, if you can see that, the bubbles coming up. And then as soon as they hit the surface, they drop back down. So why that's happening is because when the bubbles get to the top and then they pop, the air escapes, and as soon as the air escapes from the bubbles at the top, this actually allows the water to sink back down to the bottom. So you have this reverse effect of the bubbles going to the top, breaking, and then sinking back down, and that's the result of the density. So that's similar to how a lava lamp works. Bubbles go to the top, they break, and then the density causes them to go back down. So you have this reoccurring motion. And then in a lava lamp, rather than having the Alka-Seltzer tablet, the heat is actually what makes the bubbles rise, pop, and then fall. And it's, again, a continuous motion. So that is the lava lamp experiment. I probably just suggest maybe don't put in as much food coloring. I think I went a little bit happy on that. But pretty cool experiment, and you guys can better understand how lava lamps work. And then you have a little lesson on polarity and density. So thank you. If you do this at home, let me know what happens, if it worked a little bit better. And yeah, send pictures if you can, comment below. I'll have some of the steps in the description. So we'll see you next week, and it was nice talking to you guys, and I hope you enjoyed the video.